Good evening, everyone. My name is Fritz Schroeder, and on behalf of the Lancaster Conservancy, welcome to Nature Hour. Lancaster Conservancy's mission is to provide wild and forested lands and clean waterways for our community forever. We were founded in 1969 by a small group of hunters, anglers, and naturalists who banded together to acquire and protect our critical forests, wetlands, and streams with the belief that some land is so beautiful and rare that it should be protected for public benefit forever. Today, over 7,000 acres and 40 miles of trails are open for you and I to enjoy 365 days per year, thanks to their incredible vision. The urgency that drove our founders continues today as we accelerate our efforts to strategically protect and restore more fragmented forests, to expand and connect our existing preserves, and to create new preserves, all the while building out infrastructure and parking lots, trails, and signage that allow access for the public, while also protecting these incredible ecosystems. Nature Hour is a virtual education and lecture series with the goal of bringing an assortment of local and regional experts directly to your home with presentations that help you better understand both the Conservancy's work and the work of our community and regional partners. After this evening, we have one more Nature Hour this spring titled They're Back, the return of the 17-year cicada, presented by our very own Keith Williams on Wednesday, April 7th. You can learn more and pre-register for this lecture on our website, lancasterconservancy.org, under upcoming events. We will return in the fall with a new season of Nature Hours, and if you want to catch any of our past Nature Hours, you can always tune in to Conservancy TV via the Lancaster Conservancy YouTube channel. We are also excited to announce Lancaster Water Week will be returning for its 5th installment, June 4th through 12th. With over 20 partners and events, Water Week is a community festival and awareness campaign that seeks to build momentum around the beautiful streams and rivers of Lancaster County. From virtual lectures on the importance of soil and the history of the Conestoga River, to native tree plantings and guided paddles of the Susquehanna River, to after-school programming for youth, there are many ways to participate, including the Water Week Clean Water Pledge. Look for an event announcement in early April. The Conservancy is blessed with incredible corporate support, and tonight we want to recognize our annual sponsors, Clark Associates, Electron Energy, DART, Ritu Associates, Penstone, and Nimblist. Thank you to these companies for your commitment in supporting Lancaster Conservancy's work. And now it's my pleasure to introduce David Barber, a senior research biologist at Hawk Mountain Sanctuary, where he oversees the sanctuary's long-term monitoring, including its raptor count and breeding bird censuses, conducts research on the movement ecology of vultures, and manages the sanctuary's geographic information system. In the fall, he can often be found at the North Lookout scanning the skies for the migrating raptors. Welcome, David.
Thanks very much, Fritz. And thank you to the Lancaster Conservancy for inviting me. And also thank everybody for tuning in to tonight's Nature Hour. What I want to talk about today is migration, something that I've been working on and off for 20 years and something that I'm passionate about. In this slide here, we have a flock of turkey vultures migrating over Kestrel Hawk Watch in Costa Rica. And I'll tell you a little bit about those tonight. First, I want to talk a little bit about kind of the roadmap and where this talk is going to go. First, we need to talk about what is the definition of migration. Then we're going to go to where are these birds migrating, the types of migration that we see in nature, a little bit about migration timing and when these birds migrate during the year, some of the hazards or navigation, how do they get to the areas where they want to migrate to, some of the hazards that they face, and how some of those hazards is what Hawk Mountain Sanctuary is founded on, and some of the ways that we use research to study migration in raptors. So first, migration is simply the directed movement of organisms from one location of our habitat to another and recurring periodically in alternating directions. And it's really that alternating directions and recurring periodically, which is the key to migration. Now, given that definition, there are lots of different organisms that undergo migration. Pronghorn in the west, bats, we have dragonflies, humpback whales, amphibians do spring migration to their vernal ponds where they will lay their eggs. And we also have zooplankton that undergo daily migrations in the water column, up and down in the water column. But tonight, what I really want to talk about is bird migration. So there are lots of different species that migrate, over 350 species in the US that migrate, everywhere from raptors such as peregrine falcons and turkey vultures to chestnut-sided warblers down here on the left, other songbirds like a veery here in the center. And of course, a lot of people are probably familiar with waterfowl migration, given the hundreds of thousands of snow geese that come through Middle Creek every year. Now, migration is probably one of the most stressful and energetically expensive events that a bird undergoes. And for this wood thrush that is nesting in Pennsylvania, it actually spends only about 3 to 4 months of the year on the breeding grounds, about 6 to 7 months on the wintering grounds, but it's spending 2 to 3 months migrating back and forth from Central America to Pennsylvania. And this is a stressful time. I mean, scientists from Cornell have estimated that about 4.7 billion birds pass the United States southern border in the fall, heading to their wintering grounds, but only about 3.5 come back and pass through that southern border in the spring. So that's a loss of about 1.2 billion birds. Now, whether these birds are perishing during migration or on the wintering grounds is really unknown, and it's difficult to estimate, but it's migration is probably the mortality during migration is probably fairly substantial. So given those challenges, why would a wood thrush from Pennsylvania spend a month and a half migrating to Central America, spending some time there and then migrating back? Well, it really boils down to one thing, and that's food, or more specifically, the lack of food. And in fact, we can actually group birds by their tendencies, their migration tendencies, and how those migration tendencies evolved. If we have a system where there is abundant food year round, what we're probably going to get is residents or non-migrants. So species like pileated woodpecker or northern cardinals, they have access to food year round and they really have no reason to migrate. But if we have a system where there are dramatic changes in food year round or seasonally, and that is fairly predictable, what we end up with is a system of complete migrants. And what I mean by complete migrants is virtually the entire population leaves the breeding grounds and flies to the wintering grounds. So that's something, some examples are black-throated blue warbler, or on the right, a broad-winged hawk. Now, if we have a system where there's enough food for most of the population, but not in the entire population, a migration tendency evolves where we're going to end up with partial migrants. And what I mean by partial migrants is some of the individuals migrate and some of them don't. Probably a lot has to do with dominance in that system, but some of the examples of partial migrants may be American robins or Cooper's hawks. In some areas of the range, they can be found year round. In other areas, they do some migration. Now, kind of the last system to evolve is an area where we have dramatic changes of food availability, but it's very unpredictable. Some years there may be abundant food, some years there may not. And in that case, what we end up with is eruptive migration. And probably this year is one of the best examples. These are winter finches that breed in Canada, and their food crop, the cone crop, actually crashed this winter, or crashed late fall. So we had an eruption of these winter finches, species like red crossbill, white-winged crossbill, common redpoll, evening grosbeak, and pine siskins. So the biggest question is, why are these birds migrating when there's still plenty of food available? If you think about that black-throated blue warbler that's migrating late August, early September, it's an insectivore, and there's plenty of insects still around. But when we look at when a bird is migrating, we have to look at kind of two different time frames. One of them is seasonally, when that bird migrates during the year, and when the bird migrates on a daily basis, makes that day-to-day decision. And there are really two different processes going on here. During the season, it's really photo period that initiates or tends to initiate migration. So it's the changes in day length as days get shorter. There are hormonal changes that go through the bird, and this causes physiological changes. And so we start getting hyperphagia, or the bird eating a lot. And what they do is then they deposit a lot of fat, and they use that fat to really fuel their migration. These birds are flapping constantly for a very long time and use up a lot of energy. So, for example, in this picture on the left, this is a bird in winter, and this area right here is called the furcula. And if you think about a turkey, it's really the wishbone as the top part of the breast. So as a bird scientist, we can blow the feathers and we can look at fat deposits underneath this very thin skin. And this is one of the areas where fat gets collected. So in this bird on the left, we see hardly any fat. And what you should see are yellow deposits underneath the skin. However, if we look on the bird on the right, this is a bird that was caught during migration. And you can see that that furcula area is completely filled and actually even bulging. And so all this yellow that you see under the skin is all fat. Birds can put on a tremendous amount of fat in order to fuel their migration. So some of the other changes that we see in birds as they're getting ready to migrate is increased number of red blood cells. So more oxygen can pass through the blood. We have increased growth of flight muscles. So basically these birds are bulking up for migration. And what we also see is the tendency to migrate. This is it's called migratory restlessness. The German scientists called it Zugenruhe. And basically what people notice, people that have cage bird notice that at certain times of the years, the birds would get restless and try and hop, onto different parts of the cage. And we saw the same thing with a broad-winged hawk that we had here at Hawk Mountain. It was one of our feathered educators, and it often would come September, it would start being a lot more active and kind of just completely restless. So those are what's happening seasonally. On a daily basis, the decisions to initiate migration are very different. Part of it probably has to do with food. So is there enough food? Does the bird need to stay in one area and forage to get more food, or is there simply no food in that area and it needs to start moving on? But what is the biggest driver on a decision whether to initiate migration or not is weather. So birds want to minimize the amount of energy that they use during migration, so they really will wait for favorable weather in order to initiate migration on a daily basis. And we know at Hawk Mountain that the largest flights that we see in the fall are 1 or 2 days after a cold front, when we get those northerly winds, so they're tailwinds, that helps them in the migration, but it also creates a lot of updrafts off our Kinnatinney Ridge. And those updrafts allow the birds to slope soar. So they're gliding by the lookout using very little energy. They don't have to flap a lot. And it's all about energy minimalization and waiting for the right time to migrate. So they know when to migrate, but the question is, where to migrate. So this is an immature sharp-shinned hawk, and sharp-shinned hawks, like most raptors, fly by themselves. They're not in a flock. And in the case of accipiters, immature birds initiate migration before adults. So how do these birds know where to migrate to their wintering grounds? Well, we know that part of it is innate. They know kind of the approximate distance and the approximate direction that they want to move in. So kind of the classic example of this was a scientist in Europe who looked at European starlings. And what he did was he looked at, he was capturing starlings during migration up here in the Netherlands. And when he caught them, as they were moving kind of in a southwesterly direction, the end point where they wanted to, the typical non-breeding grounds for this population was in Western France. So he took these populations, or these birds that he caught, and translocated them down to Switzerland. These open dots are the adults. So when he released the adults, they were able to navigate back to what would be their traditional non-breeding grounds. However, the juveniles, once they were released, they just continued in a southwest direction at the approximate distance that they would expect to end up in Western France. However, they ended up in southern France and in northern Spain. So there's innate ability for these birds to end up where they want to go and what direction. But there's also a genetic component to it as well. And again, scientists in Europe, they were really fond of manipulating birds. And so this is a fairly common species called a blackcap. And this red area on the map on the right is the breeding grounds or the breeding range of the blackcap. Now the blackcap has different migratory tendencies depending on where the populations are in Europe. So birds from Western Europe, they tend to migrate through Spain, across Straits of Gibraltar, and then overwinter in Western Africa. The birds in the blackcaps in Eastern Europe tend to migrate around the Mediterranean, through the Middle East, and overwinter in Eastern Africa. So when scientists took individuals from these two populations, one that wanted to migrate southeast, one that wanted to migrate southwest, and bred them, what they found was the offspring of this cross, the birds, those offspring wanted to migrate in a straight southerly direction. So we know there's a genetic component to the direction that these birds want to go during migration. So they have kind of the direction and distance, but what about, how do these birds navigate their tendencies? Anytime you're migrating, there's gonna be a tendency for you to be blown off course if the weather is bad or we get strong crosswinds. So how are these birds able to navigate to the areas that they want to overwinter in, or conversely, go back to the breeding range? So one of the ways that they use, particularly for night migrants, is using a star compass. So there was a professor at Cornell University called Steve Emlen, and he came up with this ingenious way of looking at this, and it's called the Emlen funnel. So in an Emlen funnel, we have at the bottom, there's an ink pad, and there's some netting on the top, and around this funnel, there's paper. So Steve Emlen would take a bird, put it in this Emlen funnel, and in the fall, during the night sky, it would tend to jump and hit the paper and leave marks in a southerly or southwesterly direction. So it can get an idea, Steve Emlen can get an idea of where this bird wanted to go. So in order to test that the birds are actually using the stars to navigate by, what he did was go into a planetarium where he could manipulate the night sky. And what he found is when he changed the the orientation of the North Star and the constellations around that, he found that he could manipulate where this bird wanted to go. So in the left, and normally it would tend to go kind of in a northeasterly direction. When he shifted those constellations 6 hours, it wanted to go in a more northerly direction. But the stars don't really work for diurnal migrants like raptors and waterfowl. And they discovered what these species are using is predominantly a sun compass. So they can get an idea based on day length and where the sun rises, a direction based on that sun. So one of the experiments they did was looking at homing pigeons, and they would change the amount of daylight in these where the pigeons are living. And what they were able to do was shift where the pigeons wanted to return back to their loft, depending on shifting times of day. So if they increased the amount of daylight by 6 hours, the birds would tend to fly more in a westerly direction. If they decreased the amount of sunlight to kind of reset their internal compass, they would end up flying in a more easterly direction. So most people, or many people, might be aware that the birds actually use a magnetic compass. They can actually feel the magnetic Earth pole, and actually use that to get in a direction of which direction is north and south. And one of the really interesting ways that they tested this was looking at, these are Emlyn funnels, and these big bars or coils around it is resetting the direction of the Earth's magnetic pull. So depending on which direction that they wanted to change the Earth's magnetic pull, they could make the birds go in different direction, or have the tendency for those birds to kind of hop in certain directions. And believe it or not, there's actually something, they think there may be a smell compass. So particularly in homing pigeons, they have a very good sense of smell, and scientists believe that they may actually have something like a smell neighborhood. So they get to, using a sun compass, they get to kind of the area where they want to return to, and then they have that neighborhood of different smells, and they can kind of get an idea of exactly where they want to return based on those smells. Now, regardless what age of the bird that is migrating, they all face certain hazards during migration. So one of the classic examples are natural barriers, things like the Gulf of Mexico. We know that as birds are migrating south, they hit the Gulf of Mexico and they need to make a decision. Do they want to go around it, which will take a lot more time, or do they want to fly over it? And especially for species that use thermals to migrate, rising columns of hot air, thermals are much less over water. So those species are almost have to go around the barriers. And we know that birds flying over the Gulf of Mexico, often it takes all night, and they will often arrive in the morning almost completely exhausted. So they're really kind of pushing the limits of their ability to migrate across this large water body. One of the other factors that is going to influence migration is weather. Especially for these migrants crossing the Gulf of Mexico, if they get out over the Gulf and all of a sudden they are stuck with all of a sudden they encounter headwinds, they have two choices. They can either turn back, which most of them do, or they can try and push forward. But oftentimes that ends up being a watery death. There are also predators during migration that the birds have to worry about. This is a Cooper's hawk, a species of raptors that feeds on small songbirds. So predators are also a big concern during migration. And not only predators like this Cooper's hawk, but also cats. Scientists estimate that free-ranging cats kill 1.3 to 4 billion birds a year. I mean, that's not, I'm not saying that those are all migrating birds that they're killing, but some of those probably are, and especially a migrant that may be stressed or exhausted after a night of migration. This could certainly be a potential threat. But those are all kind of natural hazards, well, with the exception of feral cats. But what I want to talk about now are kind of the anthropogenic or human-made hazards. And one of those are collisions with human-made objects. I mean, these birds aren't, experienced with human-made objects, so they may not recognize them as a potential hazard. But the cost of some of these man-made objects can be substantial. So we have things like collisions with cars, collisions with towers, collisions with glass and buildings, collisions with wind turbines, and collision with or electrocution with these energy towers. So combining all these ranges or estimates of the death of birds by collisions with these human-made objects, it's 244 million to somewhere between around 1.3 billion birds that are being killed each year by collisions with these human-made objects. And it's not only human-made objects, but it's also habitat loss. This is mountaintop mining in West Virginia. And when birds are on migration, they often go back to the same places year after year, places where they know there are certain resources available where they can stop and refuel. I mean, think about what would happen for some of these birds that are already stressed, potentially looking for that habitat that they're used to stopping in. Something like Middle Creek. What would happen if the Game Commission decided to drain the lake? Not that they're plan on draining the lake anytime soon, but you're talking about hundreds of thousands of snow geese, thousands of tundra swans missing a potentially large, important stopover site where they can stop, refuel back on their way to further areas further north. And finally, global climate change. We know that the changing Earth's climate is having an effect on migratory birds. Birds in the spring in the US are returning earlier. I mean, we're not talking days earlier, but significantly earlier, in the order of maybe half a day in the spring, and they're leaving later in the fall. And we know that in Europe, that when birds return, they're often timing their migration and return to the breeding grounds often with a flux of energy, or a flux of resources, like the potentially hatching of insects, so abundance of insects. Well, those are starting to become disconnected, where the insects are emerging early and the birds haven't yet caught up. So they're arriving on the breeding grounds when there's not nearly as much food as there used to be. Now, there's this really cool website that was developed by Audubon, where they are using climate models and the potential of, as the climate increases, how is that habitat going to change? So you can plug in your zip code. And so I did for Berks County. And what you end up with is you can change several different scenarios of increases in climate, increases in temperature. And I chose 3 degrees. That's if we don't do anything to combat climate change now, the estimate is by 2080, the Earth will have increased by 3 degrees. So plugging that in and choosing 8 degrees, we find that in Berks County, there are 30 species that are highly vulnerable to the effects of global climate change with that 3 degree increase. So if we go ahead and just choose scarlet tanagers, one of my favorite birds, here on the left, we see this tan area is the available habitat or the available range of scarlet tanager. Now, if we increase the global climate 3 degrees, we see in red, this is the area where that habitat is no longer suitable for scarlet tanagers. So an increase in 3 degrees leaves, we've lost about 68% of the available habitat that is can be used by scarlet tanagers. And finally, I want to talk a little bit about hunting and shooting. And we know for long periods of time, there are lots of waterfowl hunters, and that certainly has had some impacts on waterfowl populations. But there is, maybe not in the United States, but in areas outside the United States where there still is shooting of migratory birds, and that could be just raptors. We have a migration watch site in Colombia that has just started up, and they're in an area where residents will shoot migrating Swainson's hawks and broadwing hawks. And it's really this wanton shooting that was the founding of Hawk Mountain Sanctuary. So back in 1929, the Game Commission decided that they were going to put a $5 bounty on the heads of northern goshawks. And you can imagine how much money $5 was in 1929. And the reason why is because they consider them bad predators. They would potentially kill wildlife species or game birds such as ruffed grouse. But the big issue was most people can't identify a northern goshawk. So they would just shoot and then identify later, basically. So what ended up happening is people would gather at these places where there was large raptor migration and basically just start blowing away the migrating raptors. Well, there was a young conservationist, Richard Poe from Philadelphia, who heard about Hawk Mountain Sanctuary and the shooting that was going on, and he came to visit. And what he found was people sitting on the rocks, just shooting hundreds of raptors as they migrated through in the fall. So he came back, gathered up all the carcasses, and took pictures. And what he gathered was this. And these are all mostly sharp-shinned hawks and Cooper's hawks. There's no goshawks here. Goshawks tended to migrate later anyway, when there's the abundance of migration is much less. So Rosalie Edge, a conservationist from New York, saw these pictures and decided that she needed to make a visit to Hawk Mountain Sanctuary as well, or Hawk Mountain as well. So she was outraged by what was going on, and she took the initiative to lease the land around Hawk Mountain and preserve it in 1934. She hired the first warden, who is Maurice Brune, and immediately the shooting stopped, at least at Hawk Mountain, but continued at other spots up along the Kittatinny Ridge. But what Maurice Brune also did was start counting the hawks as they were migrating through. And since 1934, we have been counting migrating hawks in the fall, using volunteers and staff, and inviting the public to witness the wonders that are the raptor migration passing north lookout. We count from August 15th through December 15th. We average about 18,000 raptors in the fall, 16 species of raptors. Our biggest migrants are broadwing hawks, sharp-shinned hawks, and red-tailed hawks. Last year, we counted 118 days and spent almost 1,100 hours sitting on the rocks counting birds. We counted 16 species of raptors, nothing special. We do occasionally get Swainson's hawks, Mississippi kites. And we averaged about 13,000 raptors. It was kind of a down year for us, but we not only count migrating raptors, we count everything that flies by. So North Lookout in late August, early September, within an hour and a half of sunrise, can be absolutely fantastic for migrating songbirds. We can look at eye level or below us in the vegetation and just watch waves of warblers move through the vegetation. We actually had a day in early September where we counted over 270 black-burning warblers as they migrated past the lookout. So 154 species we counted, and that included 12 species of butterflies and 3 species of dragonflies. And so what do we do with this data? Well, what we're trying to do is look at populations long-term. Everybody is aware of the effects of DDT had on bald eagle populations in the US. DDT causes eggshell thinning. So when birds would lay eggs and incubate, they would actually break the eggs. And it was really the data from Hawk Mountain. Maurice Brune noticed that what he was seeing was almost completely adult bald eagles passing North Lookout. I mean, a bald eagle takes about 5 years to reach maturity, and that white head, white tail plumage. So he should be seeing a lot more immature bald eagles than he was actually seeing. And it was actually our data from North Lookout that Rachel Carson used in her famous book, Silent Spring, to make people aware of the effects of DDT. And once we saw that DDT was banned in the US, we saw an almost exponential increase in bald eagle populations. And in fact, last year we set a brand new record of 559 bald eagles passing the lookout. I mean, a huge success story. We also counted lots of sharp-shinned hawks. I mean, this is one of our second most abundant migrant at North Lookout. But in the 80s, late 70s, early 80s, we noticed that the populations were declining. Now, when we looked around at other watch sites like Cape May, we noticed that the same pattern was happening. So why aren't we counting more sharp-shinned hawks? Why are the counts declining? And when we looked at Christmas bird count data, censuses that are taken late in the year around Christmas, what we found was populations or numbers of sharp-shinned hawks were actually increasing. So this is the same era where people are starting, or backyard bird feeding is becoming very popular. Sharp-shinned hawks are bird eaters. So people were supplying sharp-shinned hawks with an abundance of food in the wintertime. So again, if you have an abundant supply of resources, why migrate? Why expend all that energy when food is right there? So, and we've continued to see a kind of a short-term decline over the last 30, 40 years of populations of sharp-shinned hawks. And again, it's even though there's a genetic component to migration, migration is very dynamic, and migration patterns can change fairly quickly. But the data we're collecting in Hawk Mountain, it's a sample size of one data point, one location. So we can't say a whole lot about the population of species as a whole. So in order to do that, we partnered with three other organizations: Humana, which is the Hawk Migration Association of North America, Hawkwatch International, and Bird Studies Canada, to develop the Raptor Population Index. And what the Raptor Population Index does is it takes count data from over 75 sites in Canada, the US, and Mexico, and assesses population trends kind of range wide, as well as and population status of these iconic species. But at Hawk Mountain, we don't just count hawks, we use other technologies to study migration. And one of those that we use is satellite telemetry. So these are satellite telemetry units that we attach to the backs of migrating birds. And it has GPS and it allows us to know the location of the bird, at least every hour, sometimes every 5 minutes. So over the years, we've studied lots of species in the US or North America. We've studied or put satellite tags on turkey vultures, black vultures, broad-winged hawks, peregrine falcons, rough-legged hawks, and snowy owls. We've also attached satellite transmitters to species in Africa, Asia, and Europe. So this is kind of what we get from satellite data. These are satellite tagged turkey vultures, and each different color dot is a different bird, and the dots are locations, GPS locations of these birds about every hour. And so one of the really important things about studying migratory birds is if that species is declining, which granted turkey vultures are not, it's really important to try and determine where the birds are breeding, where that population breeds, where that population winters, and where they go during migration. So if we see a decline in a species, we know that it's coming from one of three areas: that increased mortality during the breeding season, during the wintering season, or during migration. So it's really important to term what's called migratory connectivity, connecting the breeding and the non-breeding grounds, so we can try and determine if a species is declining, where exactly are those stressors in that environment. So some of the things we're looking at in turkey vultures, since they're not really a declining species, we're looking at, this is a very common species, but the migration tendencies vary vastly across its range. So in the east, we have what we call short distance migrants. They're moving and they're partial migrants here in the east. So some species, some individuals stay, some don't, but they only move short distances: North Carolina, Florida. Birds in Saskatchewan are long distance migrants, and virtually the entire population leaves. So they're, that population is a complete migrant, and they migrate into Venezuela. And then in the West Coast, we kind of have a mixed bag. We have some short distance migrants, some long distance migrants. So some of the things we're looking at is how the migration tendencies vary, and also how weather may affect how migration, how these birds are migrating as well. And we've also attached satellite transmitters to broadwing hawks, our most abundant migrant. Broadwing hawks are a declining forest nesting species in Pennsylvania. So again, we want to determine, we know where the birds are breeding, but we really don't know where those birds are wintering and what migration paths are taking during migration. So some of the questions we're asking is, where are the birds migrating to? And we discovered that birds from Pennsylvania are ending up in the Amazon basin. So in the Amazon rainforest, areas of Peru, Bolivia, they're using a fairly consistent migratory path through Texas and Central America. But some of the other questions we're asking about is, what kind of habitats are they using during the winter time? You know, are those habitats being affected? Certainly the Amazon basin is being logged and burned at a fairly high level. And also, where are these birds stopping? What kind of habitats are they using? And are they using those habitats consistently year after year? So kind of the new and exciting project that we're launching this year is on American Kestrels. American Kestrels are a species, grassland species, that has been declining, or our counts have been declining for the last 30 years. And that's really a trend that we're seeing at almost all watch sites in the East. The question is, why is this bird declining? You know, is it factors on the breeding grounds, factors on the wintering grounds? Is it during migration? And to try and answer that, we're taking a multi-pronged approach, one of which is attaching small nano tags to these birds so we can see where they're migrating, but also monitor them during the breeding season and non-breeding season so we can try and determine where mortality is happening in those grounds. So stay tuned. Check out Hawk Mountain's website for new and exciting results from this research that we're launching this year. So I think with that, I will stop. Oh, I will say thank you, and I would be happy to answer any questions.
Thank you so much, David. Really appreciate your presentation and just such an incredible dive into the history and research that's coming out of Hawk Mountain. It's really incredible what land conservation and kind of the passion of a conservationist can do to change the tide and something and start the momentum towards just the conservation efforts that have really come out of Hawk Mountain. I just want to remind everyone that you can ask questions of David using the Q&A button on your screen. While you do that, I just want to remind you of our upcoming Nature Hour on April 7th with Keith Williams. They're back, the return of the 17-year cicada, and of course, Nature Hour will return this fall. So let's see what questions we have here for David. All right, our first question comes from Katie. One of the fascinating things you talked about was the kind of compass aspect that birds have, and just the various compasses they have. She wants to know if any other species other than homing pigeons use smell as a compass. She thought most birds didn't have a great sense of smell.
Right, and it's true. Most birds don't have a good sense of smell. Turkey vultures actually do, but as far as I'm aware, the homing pigeons is really the only species that they have looked at and found kind of this smell compass to use. So
that's really fascinating. I'm not quite over the whole planetarium with birds study.
Yeah.
That must have been fascinating. With Middle Creek being such a huge part of the local bird scene here in Lancaster County, we do have a question about Middle Creek. Knowing that that lake is man-made, what was the migratory path of the snow geese prior to the existence of Middle Creek?
That's a great question, and I'm not a waterfowl biologist, but I would imagine that they managed to find, they probably used existing cornfields to use as a food resource, but where they stopped over, they probably used other water bodies, would be my guess, and potentially, it was water bodies further south and further north. It's just now that there's a good stopover habitat, they've used that.
Kind of piggybacking off that question, how long does it take for, maybe any kind of species of bird to change their migratory habits? If they're losing a habitat, let's say.
Right. I mean, it can be very dynamic. So there's a good example from England with blackcaps that as the blackcaps were migrating southwest, some of them ended up in Great Britain. And then I think it was within 30 years, there's actually a fairly stable wintering population of blackcaps in Great Britain. So things can happen fairly quickly. The genetics probably are certainly not changing that quickly, but birds can adapt very well. And so that those migration pathways can change fairly quickly.
It's good to hear. We have a question about light pollution. We all know the turn off the lights kind of campaigns have grown more popular, which is fantastic. But which populations does light pollution seem to affect more? Is it songbirds, raptors, waterfowl when they're migrating?
So it would almost certainly be songbirds. Raptors, for the most part, are diurnal migrants, and waterfowl is kind of a mix. They migrate both during the day and at night. But yeah, it's the songbirds and this whole turn out the lights campaign is really driven by the large mortality of songbirds that are hitting these buildings at night. So it's really the songbirds that are being influenced most by this light pollution.
Yeah, great to see what Philadelphia is doing more recently in the news. We have some questions about the transmitters and the satellite transmitters.
Sure.
First off, how do you entrap the birds? Kind of what methods do you use to entrap them to tag them? And is it dangerous for them to carry those transmitters while they're migrating? Does it add to that stress that they're already experiencing?
Yeah, no, it's a great question. So how we catch them depends on the species. Turkey vultures were laying out a carcass and putting small nooses around it and trapping them that way as they go into the carcass to feed. With broadwing hawks, we're trapping them near the nest using an owl as a decoy to try and trap those birds. And then peregrine falcons, they were trapping on migration. But in order to put a satellite transmitter on a bird, it really has to be less than 3% of the bird's body weight, according to the US Bird Banding Lab. So we also look at, especially when we first started tagging turkey vultures, we wanted to know if that's going to influence the bird. It was certainly less than 3% of the bird's body weight, but we held it in a small enclosure for a little bit just to see if that affected their behavior at all. And we didn't find anything. And most of the studies that have looked at the impacts of satellite transmitters have found no harm to the birds as they're migrating.
That's great to hear. And the research and data that you're getting out of it, it's just incredible to see those maps.
Yeah. It's you know, considering that years ago, really the only way you could follow a bird was with an antenna and driving a car. Now I can sit at my desk and watch the birds as they migrate.
That's a huge jump forward in technology. In talking about the more manual ways to kind of count and study birds, we have a question from Donna. She wants to know how many people are counting during these migration periods, and what are the qualifications? It sounds like we have people who want to know how they can get involved.
Yeah, well, you certainly can contact Hawk Mountain. We always welcome more hawk watchers and hawk counters. So Humana is the kind of the clearinghouse of hawk watch sites throughout the U.S. And there are hundreds. And in Pennsylvania, there are, I think, 14 active sites in the fall. But basically, in order to count the hawks, you need to be able to identify them by sight and learn their characteristics, being able to age them and sex them in flight, so knowing the plumage differences. So it's all about practice and usually sitting down with somebody at a hawk watch site who can give you the rundown of what they're seeing and why they're saying it's this bird versus this species versus that species.
That's great. We have a question from Michael. He wants to know, going back to kind of why birds make the decision to migrate, if there's ever perhaps like a dominant member of a flock or a leader of a flock, or there's any kind of hierarchy, and if that leader makes, you know, kind of any decisions for a flock, if there's any studies on that.
Not that I'm aware of, and certainly we have done some work on broadwing hawks here at Hawk Mountain, and so one of the things that we did find with broadwing hawks is not necessarily a leader, but we did find that immatures tend to follow adults. So in that case, they are kind of learning the migration pathways, certainly through that. But I'm not aware of any species where there's kind of a dominant individual who takes charge and, you know, let's start migrating today.
So no quite human-led species type kind of work. So kind of going then back to what we can do, you know, the general populace, you know, you're doing such great work at Hawk Mountain, which is amazing, but what can we do in our properties? We had someone ask or kind of tell us that they had a Baltimore Oriole at their feeder from about the end of January, and you know, any suggestions as to the best way to help a bird that for some reason is not migrating that they usually see? Is it just because of climate change or other issues, and what can you do if you notice that?
You know, sometimes there's just aberrant individuals that, you know, don't migrate or migrate in the wrong direction. And if that's the case, then, you know, provide them with food, and, you know, eventually they may decide to migrate, or at least you're providing them with a stable food source. As far as kind of making your yards bird friendly, I would say that planting native vegetation is probably the best idea. We know that non-native species harbor much less insect biomass, which is usually what these species are eating, than native species. So it's really, you know, make your yard bird friendly by planting native species that provide both fruit and insects for those species.
Yeah, that's so true. And if anyone wants information on best native species, you can go to the Lancaster Conservancy's Community Wildlife Habitat page, and we have a great list of species for people living in Lancaster to help provide those native plant species and increase that biomass. That's a great place to start if you're looking for what you can do then to help migratory birds here in this county. We have a question about when is the best time to look for migrating birds during different times of the year? Is it early morning, at night? I know you mentioned that obviously you have different times and different species or different types of birds are migrating, but is there any general best time to look for watch?
Usually early in the morning is better. The birds are a lot more active, usually feeding a lot more during the morning. So I know at Hawk Mountain, it's, you know, within an hour and a half of sunrise, and when we're seeing the most birds. And that's usually the case, just going out bird watching in the morning. It's usually, within a few hours of sunrise is when you're seeing the most activity. And certainly that's when birds are singing the most as well. So,
a good time to bird watch in general.
yeah.
I have a question here about Lancaster County in general. The Lancaster Conservancy, we're protecting a lot of the natural lands here. And of course, these are very fragmented lands. Not much of Lancaster remains forested. And you kind of talked about these large kind of swaths of land, larger areas of land being really important to migrating species. How much does like the fragmented forest that we have in a really agricultural or developed place like Lancaster and much of the eastern US, how do those smaller preserved pieces of land kind of fit into the helping those migratory birds?
Well, they certainly provide kind of islands of suitable habitat, hopefully, along the migratory pathways. So birds can stop in and use those areas. For example, not talking specifically about Lancaster, but thinking about Central Park, New York. That is an incredible migrant trap. So birds that are migrating see this swath of green, and so it can be an incredible bird watching area. So I would imagine the same applies with these smaller fragments in Lancaster. You do have issues once the fragments get fairly small. They may not harbor the biomass or the resources that these migrating birds need, but certainly larger tracts are bigger. And they also provide, if you can link those smaller habitats into a chain, that certainly can provide, stepping stones during migration.
That's great, David. Thank you so much. And I see we're here wrapping up time just for one more question. The study you mentioned about the Kestrel decline, is there an estimate on when answers might be found or any speculation you might have about the kind of the timeline for the studies on that?
We're starting with a 3-year study. There's several hypotheses why the birds are declining. One is simply habitat loss. The other could be West Nile virus. When we tested the blood of kestrels in this area, we know that they all had West Nile antibodies in them. We also know that Cooper's hawks, which are increasing, tend to prey on kestrels as well. So there could be an influence of that. But we're looking at birds on the breeding grounds and the wintering grounds and trying to determine where that mortality is happening.
Well, I just want to say thank you again, David, and to Hawk Mountain as well, just for the incredible work that you're doing and for the research and the knowledge that you've shared with us today. I think it really just illustrates that there's just so many factors and there's so much complexity out there when we're looking at just the intricacies of how we and our actions as humans kind of impact wildlife, bird species, and all of that, but also the hope in what we can do, through actions like the conservation efforts at Hawk Mountain and the research that's happening there, or the work of the Conservancy. You spoke about kind of connecting and expanding land, and that's exactly what we do with our land protection efforts, is build our preserves piece by piece until we have a pathway, along kind of incredible migratory places like the Susquehanna River. And just some of the other, natural lands that we have that we're trying to connect into larger parcels. So David, just thank you again. And thank you to everyone for joining us today. We're really grateful that you took time out of your day to learn a little bit more and to dive into migration with us. We hope you'll join us for our final nature hour of spring of 2021. And thank you again. Have a wonderful evening.
Thanks.
Thank you, David.